Okay, I think I forgot to record this part in the class, so yeah, this is actually our continuations after we discussed last week the sketching the graph. Okay, so if this is your functions, okay, this gx, okay, it's 1 over x squared minus 1 over x minus 1 squared, okay, and then you need to sketch this functions into a graph. Okay. So first thing is, one thing that you can see from the function is the domain. Okay, so obviously x is not equal 0 and x is not equal 1, right? Because if you plug in those two numbers, the function become undefined, right? And then the other thing is you can check the intercepts. Okay, so you can check the intercepts. You cannot have x 0, so you can check the y equals 0 or f of x is 0. So checking it's 0 solves the x, and then you find that your x is actually half. So at this point, you will have the curve, okay, crossing this point. Okay, and then check the asymptote. So first checking as x approaching infinity, checking this will be 0, and checking this part by dividing with the highest degree of x, it also 0. So y0 is our vertical asymptote. And same thing with the vertical asymptote, we can check as x approaching 0 and 1 from our domain. So we will have this is our vertical asymptote. Okay, so x equal 1 and x equal 0 is our vertical asymptote. Okay, at least we get the asymptote now. And then the next session is, from these functions we find our first derivative. Okay, if you want to solve this and checking all these solutions, we will get the conclusion that this quadratic function has no real solutions. Okay, so it will be having imaginary roots. Okay, and from here we still need to check the g prime, whether it is greater 0 or g prime less 0. So based on our asymptote 0 and 1, we check all the possibility of the signs. Okay, so we check putting some x here, putting x here, and check whether it's negative or positive. And here's the results. Okay, so you can check -1, check maybe fourth or half. Okay, and then also maybe 2, you will get the increasing function is at negative infinity until 0 and 0 until infinity, and decreasing function at 0 and 1. And then we derive once more to check our g double prime. So also from here also we can conclude that gx has no critical point. Okay, because you cannot have real solutions from this function. Okay, then let's move on to the g double prime. So we derive this g prime, so this is g prime, so we derive and we get this. We can make simplify this, and we can also expand this x minus 1 with 4, and we get this form. Okay, and to check the inside, we'll have to this polynomial functions in degree 3. Okay, and if you remember how to solve the polynomial, we can check. The first is possibility of roots. Okay, 1 divided by 4, factor of 1, factor of 4. So factor of 1 is only plus minus 1, and factor of 4 is plus minus 1, plus minus 2, plus minus 4. So our possibility of roots is 1, half, and 1 over 4. To check which positive or negative that we want to try, if you want to check the signs, we can check through the Descarte rule. This is actually a basic formula in the polynomial. We check the positive x. Okay, so this is just the original functions. We see there is an actual change in signs. So this is positive, right? So we count this as 1, this is 2, this is 3. So 3 changes. So we say if we have 3 changes, the possibility for the positive roots is 3 or 1. So it's basically the Descarte rule. So 1 is from 3 minus 2. Okay. So this is 3 minus 2, it's 1. Okay. So it's not the exact results, but it's the prediction. So it can have 3 positive zeros or roots or 1 positive roots. Okay. And the second one is checking the negative x. So we are putting negative x into our original functions, and it's resulting all signs is negative. There is no change of signs. So we say there is 0 negative roots. Okay, so we can make a table. So 3 positive 0, total is 3 because we have x cubed. Okay, so every polynomial with the highest degree, the possible or the roots should be, for example, if this is 3, then the total roots should be 3. So if it has 3 positive 0, so total 3, so there is no other roots. Okay, that's this first case. Okay, second case, it may have 1 positive zeros because it's 0 negative root, and then the other 2 will be imaginary. So it's resulting this this case. Okay, and to check our root, because we know that it may have the positive zeros or positive roots and no negative roots, so we check from here, we check all the positive. Okay, and by synthetic division from polynomial, okay, we get the result is 1/2. So we can have this as our expansion. So we may have x equal half as our inflection point. And then this is the whole g double prime. So let me write 0, half, and 1. This is all important points to check the g double prime. So we check this half, okay, and we check the some maybe negative 1 here, maybe 1 over 4, maybe 2/3, maybe 2. Okay, and check, and you will get this is positive, this is negative. Positive means it's concave upwards, and negative means concave downwards. And we shall draw the graph. Okay, so first, based on g prime, it's increasing, decreasing, and increasing, but it's increasing in concave upwards. So before 0 it should be concave upwards, so it's concave upwards. But remember, you have asymptote in 0 and also this y0. Okay, so you need to have upwards like this. Okay, so you are getting closer and closer to the asymptote line. Okay, and in the after 1, it should be increasing, but it should be downwards. So it's increasing but downwards. Okay, and in the middle it may have all is decreasing. Okay, it's all decreasing, so it should be going down, right? But the before half it's concave upwards, and then after half it's downwards. Okay, so this is the results, and the actual graph is like this actually, but you cannot really see what is happening here because the scale is not really that good. If you zoom in, you will see it's actually having a slight change in concavity.
Yes. Hmm? The QR code later, okay? Because I think the system have problem. Okay, while you're maybe see some of the questions here, maybe you can check which one is you think you need to solve. Maybe I think the first one is easy or not. The first one, sine tangent inverse x and derive. I think it's not too difficult, right? Uh, Maybe check which one is for you difficult and try to solve. And then maybe I will show you one or two, and I will give you another questions. So actually, the whole calculus, okay, we will have at least in the derivative part, um, we will have the definitions. Okay, first is definitions. How's the functions continuous, differentiable, and so on and so forth. And the other one is techniques, how to derive. And this is basically the techniques how to derive. And we also have the solving the tangent line. That's one part, tangent line, and also implicit differentiations. But usually it can be both. It can be combining most of the um, techniques in one question. And also you have the linear approximations, related rates. So from 1, 2, 3, 4, um, which one you think you need most for guidance? All? No, right? I think number one is not that difficult, right? You can use the chain rule to solve sine tangent inverse. And my suggestions, if you have this inverse of trigonometric, um, always refer to the basic definitions using the triangle. Okay, using triangle and define the x and the theta. Okay? If you maybe forget how to solve, it's okay if you want to memorize some of the tangent inverse, sine inverse, the derivative, but it takes time to memorize, and I don't like it. So I just use basic definitions, and I think it's not too difficult. So from 1, 2, 3, 4, um, do you think which one do you think uh, you need some help? Number two. Number two. Yeah. How about number one? Can you do it? Number one. Or all? Four? Can you do it four? Okay. Four is quite long, you know. The it's one, two, three. It's not that long. Four is quite long. Okay, you try first, okay? If you feel not confident in math, just tell me, okay? I will guide you. Well, you need to change to in the X form. Yeah, with variable X. Yeah, change to like this. Mhm. Yeah, implicit. You can do implicit, and maybe you can make this like half, right? With half power. Yeah, like that. Yes, dy dx. Yes. Yeah, and just solving. Can you do? Can you do which one you can do? Yeah. Mm-hmm. Yes. Correct. Sign U. Mm-hmm. No. Yeah. To become what? Yeah, cos U. Yeah. And also derive with du dx, right? Mm-hmm. And du dx is you get from here. You derive this, and you multiply with the derivative of this. Mm-hmm. No. This is you need to have special case here. Tangent inverse. Actually, the answer is if you derive this is become 1 over x squared plus 1. But do you know where this comes from? So let me tell you this. Okay, if you have a theta, it's tangent inverse. And your tangent theta is x, right? You can start from here. Where's tangent? Tangent is this over this, right? So x and 1, right? So to become here. And here you have 1 plus x squared, right? And try to derive this. Derive with theta. Okay. Wait. So this becomes secant squared and then d theta dx equal just 1. So your d theta dx is actually your derivative of tangent inverse. This is actually 1 over secant squared theta. And how you get secant squared theta from here? You get cos theta is 1 over this, right? You square this and you get 1 over, okay? But if you just want to memorize this, that's also fine. But sometimes maybe you forget how to solve this. Yeah, so this will be cos. This is tangent inverse x, and then this is the answer. So, and from here, the theta that we already defined here. So cos theta is 1. So we just multiply, right? So that's the answer. Okay. Yeah, I think it's correct. Yeah, I think it's correct. It's also, I think, correct. Uh, number 2, number 1. I think it's better if you also change this into x. Uh, okay. Because tangent inverse is our angle theta, right? So you need to find the cos theta from the tangent theta. Okay. Let's try several cases. Maybe I will try 2 for you. Okay. Let me just start with number 1 and number 2. Okay. Okay. Number 1, sine tangent inverse x. Okay. So if you want, okay, you can define the angle first. Okay. For example, let let the theta is your angle. Okay. Okay. Because tangent inverse is actually resulting in angle, right? So let's just say we have theta, and we can say that tangent theta is our x. Okay. We can start with the triangle, or maybe bigger one. Okay. So first, we define our theta here. Okay. So our tangent theta is x over 1, right? And the hypotenuse will be x squared plus 1. Okay. And then we define this and we derive. Okay. So derive tangent theta will be secant squared theta, and then d theta dx equal 1, right? So theta is actually our y, our functions, but let me just write in theta so that it makes sense. It's the angle. Okay. So d theta dx is 1 over secant squared theta. Secant squared theta, we can also change to cos squared theta, which is cos theta from here is 1 over, and you just need to square it, and you get so this is the tangent inverse, only tangent inverse. Okay, you get this. So when you have this, you find dy dx is actually using the chain rule. Okay, using the chain rule, you get cos right tangent inverse x, and then multiply with derivative of tangent inverse, which is this one. Okay, or I will write one by one. Okay, so the dx of tangent inverse x. Let me change the tangent inverse to cos theta. And tangent inverse, we derive 1 over 1 plus x squared. Cos theta we get from here is 1 over square root of x squared plus 1, right? So we change the cos theta here. Let me change to half. And we can write this as so that's the answer for number 1. Okay, any questions first? Okay, then let's move on to number 2. Number 2 is actually a product rule. Okay, so the first function is on the x, and the second function is g. Okay, so we can start with the writing the, maybe if you want, write the product rule formula first, that's fine. Let me just write f prime g plus g prime f. So this can be written as sine inverse x, and then plus x, and then d dx of tangent sine inverse x. Oh, we still have more to derive. Okay. We can start with the triangle one. So every time you forget, start with triangle. And let the, now it's sine inverse. Okay. Sine inverse x. Okay. It's theta. Okay. So sine theta is x. So x, and then this is 1, right? And the other part will be 1 minus x squared, and you have square root. Okay, so let's derive this. Okay, d dx. So cos theta d theta dx is 1. So d theta dx is 1 over cos theta. So cos theta is square root 1, and 1 over, then it will be 1 over and also from this triangle we have tangent theta is x over square root of 1 minus x squared. We can change it to the first form. Okay, to the left, we can change the tangent sine inverse into this. Okay, and then we still have this part. So let's derive tangent sine inverse. I'm writing tangent. Let me write sine inverse as theta. And derive this, or maybe I'm writing the maybe write in the another page, so it will be better. Okay, so tangent inverse, or tangent, derivative of tangent, remember it will have secant squared, right? So secant we get from here is 1 over secant squared is so dy dx. plus x 1 minus x squared for the tangent. And then you need to multiply with the sine inverse is, where's my sine inverse? This, right? Okay. I think you can simplify uh, simplify the denominator, and you will get uh, x. Okay, you get it? This is from the tangent, and multiplied by x, and then the sine inverse as the chain rule will be from here, from the chain rule, or yeah, here. Okay, it's quite complicated. Okay, but basically the first step is defining the function as the product rule first, okay? And then you derive, and you have also still derive this one, and this derivative, the tangent inverse we already discussed. It will have 1 over 1 uh, 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 minus x squared from here. Okay. Okay. Yeah. Okay. Any questions? So maybe I will write to help you get what this is about. Okay. This is if you want to see what it should look like in the theta. So basically, this is tangent theta. This is the theta that I define in whole equations. So tangent theta from here, and then this is the x is multiplied by 1 over 1 minus x squared, which is the secant squared. It came from the tangent. Derivative of tangent is secant squared, right? And then we multiply with the inside derivative of sine inverse is from here. It's secant theta. Okay, so that's why you have these multiplications. Okay, I hope it is not confusing. Okay? Okay, I will move on to another sections because we still have several. Um, And we will have L'Hopital rule, okay, in our quiz, okay. So this is just a review how to solve this limit, okay. So obviously, if you plug in 1 to here, it will render 1 over 0 and 1 over 0, which is infinite minus infinite, right? We call this form is indeterminate form. Okay. So to solve this rational, okay, one idea is to simplify the rational functions first. Okay? So you have x minus 1 and ln x. So this x minus 1 minus ln x. Okay. Now what? We check with 1. We try to see what it looks like when we plug in 1. Okay? So this become 1 minus 1 minus 1 minus ln 1. And then it's 0 and 1. So of course this is now becomes 0 over 0 situation. Okay. Now this form, okay, if you have 0 over 0 or infinite over infinite, you can use L'Hopital rule. Okay. So that's how you are using the L'Hopital rule method. Okay. So from here, we can move on to our L'Hopital rule. Usually you write LH in the method, or you can just saying using L'Hopital rule in words. That's also fine. And then we derive the whole thing, both top and bottom separately. Okay. So 1 minus 1 over x. Okay. And then the bottom one will be, we can say this is a product rule. So ln x plus 1 over x, x minus 1. We check with still x equal 1. Okay. We check with 1, 1 minus 1, ln 1 is 0 plus 1 minus 1. So it's all still 0 over 0, right? Okay. So in L'Hopital rule, you can use it as long as it still has 0 over 0. You can use another L'Hopital rule. So you can derive once more. It become it's 1 over x. Let me, it's become 1 minus 1 over x. So it's minus and it's become plus. And then we have, when we plug in 1, it's become 1. 1 plus 1, it's half. Okay. So as long as you get 0 over 0 or infinite over infinite, you can always use L'Hopital rule. Okay. Okay, that's the L'Hopital rule. Okay. Okay. Any questions? I will give you one more review questions. Let me give you questions related to the the tangent line. Okay, let me give you this one. Um, for okay, so you have some elliptical region here. Okay. You have a lamp. It's giving light through the ellipse. Okay. You have the equations of the ellipse. If this -5 is on the edge of this shadow, so it's the shadow situation, and it's asking this the height of the lamp. So the lamp is at 3 units. So you have -5 here. You have 3 from here, according to the XY coordinates. You have the ellipse. You have the height. Okay, what is the idea here? How to deal with these questions? Okay. You have an ellipse. You have some light here, and it's not related, right? It's not moving, right? So we just you see it as it is. Okay? It's static, right? It's not moving. So this is the ellipse. So here, the figure is actually helping you to see the problem. Okay? In ellipse here and here, at these 2 points, okay, these 2 points here, you have a straight line, right? And this is also a straight line here. So you have 2 points that touch the ellipse from these lines. Okay? You have the equations here. So first, you need to figure out what is the relations between this and the tangent line. Okay? And when you get it, you can see you have -5 here, you have 3 here. Of course, this is -5 and 0. This is 3, and you know this 3, 0, right? You know the length, you know the tangent line, and then you can combine all. Okay. But first, you need to check the tangent line first. Check the equation, what you can get from the tangent line. Okay, you can try. You can try for yourself. Okay. I will give you several minutes to solve. Maybe 5 minutes. 5 minutes. 5 to 10. I think you don't need to. You have 2 points, right? I think you just need this point now. This point. You just need this point. If you know this point, you will know how to get this coordinate here. So you get the gradient, okay, and you have points. You can get also linear equation from this point. You can check the gradient from the derivative of this. Maybe you can name this point with some, maybe A, B. This is the -5, 0. And this is 3, and let's say H. Okay. So this whole thing is H. So you can solve the differentiations, the derivative from here. You can use the implicit differentiations, get the gradient, and check the gradient with some any value from this point here. And you can check also with the gradient from the tangent. Okay, so H over 8, right? The tangent is y over x, right? You can also check with that. Mhm. Find the linear equation. Mhm. Yeah, yeah, yeah. Delete the slope here. Yeah, and the slope at this at yeah, yeah, and AB. Yeah, yeah. Mhm. Yeah. Yes. Yeah, you get this first, right? Um, you can check these linear equations with the yes, yes. So you check. You have two segments, right? From here and here, right? So you have at least two equations from here, right? Based on the points. Yes, yes, yes. Fine. Oh, yeah. You see, you have the linear equation, right? You have 3 points. You can say this one, two. So this equation here, here, right? Okay. Let me derive the functions. Okay. So the functions we can derive through the implicit differentiation. So we have 2x plus 2y. Oh, wait. This, let's say 8y dy dx. And dy dx will be negative x over 4y. So this is the gradient. Okay. So gradient. And at the a, b, our gradient becomes and from the picture, we get the gradient is the height over A. So this is 3. This is 5. Okay. 5 plus 3, 8. So this is equal H over A. So this is our second equations that I think important. And from this straight line, I will denote this is the first segment. This is the second segment. Okay. So we can find linear equations with the same gradient from these 3 points. Okay, the first equation and second equation. So from the first equations, we get y b, right? B minus 0. Let me just write 0, and then the gradient is negative a over 4b, and then this become a minus minus 5. It's a plus 5, right? And the second equations will be h minus b, same gradient, and this is 3 minus a. So we have all these equations. And I think this is enough for us to solve and find the whole equation. Let me solve the 3 first. It's b. I will write this as b over a plus 5. Okay. Let me solve this for b squared is equal negative a squared minus 5a. Okay. 4b squared plus a squared is equal negative 5a. For b squared plus a squared. See here? It's 5, right? So it's 5, right? Right? Okay. So because the ellipse will be having the same ratio, okay? So you will from ellipse so you can write this 5 is equal negative 5a. So a is negative 1. And then we can solve the other part. For b squared is 1 minus or plus 5. Or minus 1 plus 5. Yeah. So 4b squared is 4. So b is, it's actually plus minus 1. But according to our picture here, it's only possible if b positive, right? So let's having b positive. So only positive. So I will write A is -1, B is 1. Okay. And then we have negative A for B is H per 8. So this become 1, 4. So H is 2. Actually, you can also solve the fourth equations and compare with the third equation, and you can solve also. But because I already see this 4b squared plus a squared is actually our ellipse equations, right? So we can say that it's equal to 5. And we get the A, we get B, and we plug into our gradient equations, and we get the height is actually, it's 2 units from 0, 2 units from 0. Okay, any questions? Yeah, we don't need it. Yeah. Actually, we don't really need the 4, but if you want, you can choose between 3 and 4, which one you want to solve. Okay. Okay, any questions? If not, then um, for the quiz, um, at least questions like the tangent lines will be there. Um, the techniques to derive also, how to derive, like I will give you the function and you need to find the first derivative. Linear approximations, maybe I will consider also, and L'Hopital rule. And of course, the questions may be about the definitions, okay? What is the functions and etc. Um, so the total will be around 5 or 6, maybe less, maybe 4. And also related traits 1. Okay? So maybe 1, 1, 1. Yeah, maybe around 4 or 5 questions. Okay. And maybe one more thing about the midterm. I said in the beginning of the course, maybe we will have the midterm on 20 of November, okay, not 16. Okay. And can you check? Have you checked one more time? Scan the QR code.